Hi guys, welcome back. And now we're going to talk more about SQL joins. So in this session, in this class, in this episode, we're going to talk more about what SQL joins are and how we use them. So without further ado, let's begin. Now, if you're here for the first time and want to learn more about SQL, you know that I am be making this continuous series. You would find previous lectures already on my channel and more to come. So don't forget to subscribe. Let's begin. So let's talk about SQL joins now. Now, what are SQL joins and how we use them in our database? SQL joins basically are one of the most important aspects of writing your queries, and this is something that you will be using continuously throughout your database and SQL journey. SQL join basically allows us to combine the rows of two or more tables. The basic idea is that we take data from two different tables and join them together. Okay, and then there are various ways to do that. So that's why we use the word join, meaning joining the data from two different tables in form of rows. So we take rows from one table, rows from the second table, and then we join them together based on the related columns between them. So there needs to be a related columns between them, so a relation has to be established. So this is where our primary key and foreign key relation works. So for example, let's look at the tables called order. So we have a table called order that contains order ID, customer ID, order date. Okay, so this is an orders table that contains, hey, this is a new order given by this particular customer, and this is the order date. So if you look at the customer table, now it also contains something called customer ID. This is same as this ID, and then it contains the customer ID number, the name, the country, and the XYZ details. So this basically means now the relation is there between customer ID from the customers table to the customer ID of your main orders table. So this is a primary key here. This behaves like a foreign key here. Now this is where we start to use join. We take and match the customer ID. This is what the relation here is talking about. So we take the relation between one table column, and then put it in the table column of the second table, and then we use these two things to join the data. So notice that the customer ID column in orders as well as in the customer table are both the same. This is how the relationship works. So the relation between these two tables is based on the customer ID. Okay, now we're going to use this to use or write our join. So then we create the SQL statements that contains the inner join that selects records that have matching values in both the tables. So the matching values we use and we obtain through this condition. Here we say, hey, find the orders column ID, customer ID, and then the same customer ID exists in the customer table. Find them, equal them. When the both customer ID matches, then get the record for me. So this is where the relation works. Let's talk more about the join statement for now. So when we write this, if I execute this code, okay, what we get table of rows that combines the data from orders as well as customers. But how we do that? We do that using something called inner join. So now what we have done here is we have said, hey, select orders.order ID, customer from customer name, and orders from order date. So you take an order ID from the orders table, dot comma customers dot customer name from the customer table, comma order date from the orders table. Okay, so now note this sequence that we have written this, because this is the exact same sequence that our output is going to be. So this sequence here of how we want to display our table matters. So if I write this table first, that means that in my output this table is going to come first. So if I write here comma and remove this comma here, run this query, now you will note that order date is the second column and customer name becomes the third column. So this order also matters. Now what we have done here is that, hey, go into orders table, find me the order ID, take column name, go into the orders table, order date column, now go into customers table and find the customer name. But which records do I need to show you? Should I show you every single record? So no. Wait. From orders table, get these two columns, then inner join. Okay, inner join customers. So join it with the customer table on orders ID is equal to customer ID. So now what inner join means that, hey, I want to join these two tables together. So join the data from the customer table as well. On basically means the condition here. On which condition do you want the join to work? So we say where customer ID is same in both the tables. So for those records that have the same customer ID in both the tables, find the records for that. So customer ID 123, customer ID 2. So if in this case only the 2 record will be sent, because only 2 record is same. But obviously this table here has multiple records, so it contains all the records. So all this data that have the same customer ID are basically returned to us. Okay, so this is typically what join does. It combines the data together using the inner join clause. Customer, the name of the table is, on basically is like a condition. So on this condition, based on this condition, in which we say the customer ID from the both these tables needs to be same. Okay, so we get this output. Now, obviously, inner join is not the only type of join we have. We have multiple different joins. How they work, let's explore that in a moment. So now we say that in MySQL, we have inner join. We just talked about this a little bit, but we also have something called left join, right join, and cross join. So typically, we have four types of joins that we can use, and we're going to explore each of them in detail a little bit in a while. So stick around. Now, let's talk about inner join. Inner join returns records that have matching values on both the tables. So if this is table 1, this is table 2, the inner join will find the same data that exists within both the tables and return only that particular data. So that's why we use this equal to clause. So find the customer ID in orders table and the customer ID in the customers tables and make sure when they are equal. If they are equal, that means that inner join will work, and then inner join will only fetch the data that is exactly same in both the table. It's data based on customer ID. Okay, so we get the data based on the customer ID for the records that have the same data. So that's what inner join does. Then we have something called a left join. What left join does is it says that they return all the records from the left table. So return all the records on the left table and those records that match with the right table as well. So I want, for example, table A contains 10 records in total, and table 2 contains probably 20 records. So total we have 30 records. But when we use the left join, this syntax says that, hey, take all the 10 records from the table 1 and all those records from table 2 who are also same or exist in table 1 as well. So we will get only the selected amount of records here, 10 plus the matching records. In this case, only the matching records. This can be 3, 4, 5 or whatever matching records we have, only those records. But this says, hey, show me all the table of all the records of 10 of table 1 plus the same records. This is what left join does. Then the right join, obviously now it would basically mean that fetch all the data from the right table and the matching records from the left table. So show me, if this contains 20 records, show me all the 20 records plus those matching records as well. So the right join will combine the table from the right side to the left. Left will combine the data from the left side to the right. And then there's something called cross joins. Return all the records from both the tables, meaning return all the records, the similar, the dissimilar, all the thing. I just want to take the record from table A and table B and then put them together without anything, right? So these are four typical types of joins that we get. So if you understand these basic concepts, that how each join is working and what type of data it represents, now let's move on to inner join and explore this concept a little bit more further. Okay, so coming to inner join now. As discussed already, inner join is a keyword that selects records that have matching values in both the tables. So we have table 1, we have table 2. Regardless of how many records exist in each of these tables, it will only return those records that are exactly same. The way we write it, we say selects the column names from table 1. So table 1 becomes this one. Inner join table 2, now join with table 2. On is again a keyword that we use with the inner join. This on specifies the condition. So we say table 1 column name is equals to table 2 column name. So this will give us that both the records that are same, only those records are returned to us from table 1 joined with table 2. Okay, so assumingly we have database. In this tutorial, we're going to use this default database. We have a custom orders table and we have a customer table. Then we say, in order to write the join, we explore the same thing. We just talked about this in a moment ago. So we're going to say, hey, listen, select orders from order ID. So go inside the orders table, find out the order ID, and then go into customers table and find out the customer name. So I want to know which customer placed which order, basically. So we ordered, the detail of that is in orders table and the name of the customer is in customer table. So we use the inner join. So we're going to say customer on orders dot customer ID. So the customer ID that exists in the orders table must be equal to customers dot customer ID, meaning in the customers table. Okay, so if you run the query, now you're going to get the records of only those people who are exactly same and whose ID actually exists in both of these tables. Okay, so we get all these wonderful people name. That's what inner join does. So inner join, what if we want to join more tables? Obviously you can do that. How are we going to do that? So inner join keyword selects all rows on the both tables as long as there's a match between the columns. If the records of the orders table do not have the matches customers, there will be no table shown. Do keep this thing in mind. Now let's talk more about these three tables. So the following statement is there, and it basically now combines three different tables and combines this data together. That's what typically join does. You use join to combine data from multiple tables. How do we do this? In terms of if there are more than one table we want to join, we say select orders.order ID. So again, do note that the prefix table name has to be there. Customers.customer name, prefix customers table, comma shippers.shipper name. Again, prefix is there. The table name dot the column that we want to refer to. So the dot operator here behaves like a connection operator. It connects the table with the column name. So it's going to say, hey, listen, go into the from orders, and now note the brackets. In order to combine 3 or 4 or 5 tables, the brackets play a key important part. So let me explain these brackets to you. So what we now are going to do, so we're going to say, hey, from orders, and then we have this order ID bracket close here, and oops, in a join, let me just simplify this, and then I'm going to say, once we have this, then go inside inner table and then put this here. So now what we're getting is a simple, can I extend this little bit if I can? Now if let's try to read this and try to understand what we're doing. So we're saying, hey, go into select, find order ID, customer name, shipper name from all these three different tables. But how do we combine the data? We're going to use the join. So we say from, now this typically contains the table name. Okay, so we're going to provide parentheses. So this is the main parenthesis, and then this is going to be the inner parenthesis. Okay, and then once this is there, this is how it's looking. So we say bracket start, bracket close, semicolon. So we give a first bracket. Inside the first bracket we wrote another bracket here. We say orders, so this is one table name. Inner join customers, so join customers with the orders table. On orders, the customer ID is equals to customer ID from both these tables. So this becomes a typical standard one join. But then we close the brackets here, and then we write another query here. Then we say, hey, let's do one more inner join with the shippers. So first it's going to combine the data with this thing, then it's going to go into shippers table and come get the data from that as well. On, again, which condition is that we say find out the orders.shipper ID is equals to the shipper ID. So we're going to match the order data first with the customer ID, then within the orders data, the shipper ID. So if you look into the orders table, okay, this was our orders table. So order table has an order ID, it has a customer ID, but it also has something called a shipper ID. So within one table, we have information that, hey, this is your order ID, the customer who placed the order, the employee who took the order date, and the person who's going to ship it. So this each information is normalized into this simple setup, and each table has a unique ID. So this customer ID is referring to the customers table. The shipper ID contains ID of the information that the shipper table has, this one. So if you run this query, we get the details here. Now the details show us the order ID. This is the order ID, the customer name. Based on equal operation, based on the join, it fetches the customer name from the customer table and the name of the shipper from the shippers table. So we can see, hey, this is the order placed by this guy, and this is the shipper who's going to ship this particular order. This is how a multi-join system works, where we have multiple joins or nested joins. We use these brackets to separate these things. So these brackets are key thing. Okay, so if you place them in just proper order, you can understand. So we have orders.inner. Once this bracket start, bracket close, then after that we use another inner join and we close this statement. So first this join is going to execute. It's going to find out all the customer IDs and the similar customers from the customers table, and then based on that, it's going to say, hey, okay, now I need a shipper ID from the shippers table as well. So it's going to find out the shipper table. And join simply combines these three queries or three tables data into one single thing. So you can do that as well. Understand? Capiche? Very easy. If you understand this logic, the next basically follows the repetition with the change of code. Just one word. So now we're going to do something called left join. We talked about inner join, the similar data. The left join is where it fetches all the data from table 1 plus the same data from both the tables. How it's going to do? This is the typical syntax. Select the column names, from table 1, left join table 2. So this table 1 is written with the from keyword. So whatever you write with the from becomes your table 1. And then you can say left join table 2. So this becomes your table 2. On, again, this word is used here, condition, and we say table 1 column name to table 2 column name. So we're going to match table 1 column name with the table 2 column name. And whatever is similar, you return with that. Because we have used the left keyword here, this means that bring me all the data from table 1 plus join it with the same data that exists on both these tables. So as demo, let's explore it in example. So we have two databases available. This is how we write the query. Okay, so now what we're going to say, hey, find out the customers. We said, okay, I have a customer, call customer name and orders ID from order ID. We say from customers, fetch this data. I said, okay. Then we're going to say, hey, left join it. By left join means that I want all the data from the customers table plus the similar data that exists in the orders table. So I'm going to write on customer.customer ID is equal to customer ID. So if I execute this query, if I execute it, it should give me the same data name. Okay, and it's not working. Oh, okay, it's still compiling. Because we have used the joins, sometimes joins can take a little bit more time to execute, depends on what exactly you want to do and how many records you have. Okay, anyway, so now we get all customer name from the customer table and the order ID from the orders table, and the records that are showing us that we have all the customers and only the record order ID for those customers whose records we have matched. Okay, so we get the data in this order. Finally, we have done order by. Again, I've talked about order by previously as well. I've used order by clause and I've said, hey, go into customer tables and sort this with the customer name. So order by basically will sort the record based on the customer name. Done? Capish? This is left join. Same syntax, we just use the left join words. Similarly, we have a right join. Again, same syntax, just we use the word right join now. So if you understand the concept of how it is working, you just now use two different words depending on how you want to work with it. So right join will say, hey, find all the data from the table 2 plus the data that's same in both these tables. So you say select column names from the table 1. So table 1 becomes your normal table. Right join with the table 2. So table 2 becomes the right join. So all the data from table 2 will be given plus the number of records that are exactly the same. And then we're going to write the condition on table 1. Same example, same thing. This time we just written right order. So we say select order ID, employee last name, employee first name, orders table, go inside the orders table and find me the order ID. But right join with employees. So because we want to do right join with employees, so all the data of employees will be this time represented. Okay, and we will get the data from there. So if I execute this code, we get last name, we get first name of all the employees plus matching order ID for those records that have the same data. Okay, so it's going to go and fetch out all this data, all those employees who have placed the order and give me those records. Then obviously we have used order by, this time order ID. So we are sorting the data based on order ID. So sort this data based on the order ID. That's why we have different name. I can say, hey, sorted by the employee ID or whatever record you want to sort it out. Just table name dot the table column name. It will sort based on that. So we can say, listen, I want to sort the record on based on this employee's name. So control C here, and I can come here and I can say, let's control V, run SQL query. Now what it should do is it will run the query and sort the data based on employee's name. Okay, it's executing. Come on, what happened? Somehow it's not working. Okay, so anyway, it's taking longer than expected. So this is right join. So now finally we have the fourth type of join called cross join. The cross join is basically a keyword that returns all the records from both the tables, and it works in similar way. We say select column name from table 1, cross join table 2. There's no on keyword because again there's no point writing a condition. We are already asking it to combine the data from all possible types. Do remember that cross join can potentially return a very large number of result sets. For example, if you have 1,000 records in one table, 1,000 records in second table, if you use a cross join, it will going to combine them. Now you're going to have 2,000 records. But if your records increase exponentially, that means that it will double the record of based on your query, right? Because it's returning every single thing. So we need to be careful about that, and that's why it can take some time extra, because it's fetching all the records together. So for example, we again have a same demo databases, and we're going to perform cross join on them. So when we do select customer name, orders ID from customers, and cross join them. So what this will do is that if I run the query, it's going to give me customer name, order ID of all possible records that exist here. Okay, so now I get all the possible records from both these tables combined together. I said, okay, wonderful. So note, cross join keyword returns all matching records from both the tables, whether the table matches or not. Because we have not used any on keyword like in the previous examples, there is no condition here to evaluate. So it's going to return all the records from both the tables. So we need to be specific with that. Okay, so if there are two rows customers that do not have the matching orders, if the rows if there are rows and orders that do not match, then customers, those rows will still be listed. So it doesn't really matter if there are rows and columns that match or not match, they're going to return everything. So if you add where clause, if the table 1 and table 2 has a relationship, the cross join will produce the same result as the inner join. So you can use a where clause to limit what records you get. And if the relationship has been established based on the customer ID or order ID, this now will behave same as inner join. So it will only fetch those records that match, not all the records. So if you use a where clause with cross join, you get all the records. So sometimes you might come across, hey, I want to see all the records in these both tables. You can use cross join, but usually we do not do that. And if you put a where clause in this, this actually becomes exactly same as the inner join. So either use inner join, it's much more easier understandable, or if you just want to use for the sake of it cross join, use it and then just put the where clause in. Okay, so this concludes the 4 main joins. Then we have something called self join as well. This is the 5th one. Self join is a regular join, but the table is joined with itself. Okay, as the name specifies, you are joining the same table with itself and returning the duplicate data, in other words. So the way we use this self join is that we say, hey, select column names from table 1 where condition. Okay, now note, this table 1 here is, and there's table 1 here is. So we are using the same table twice. That's what we self join is, but we're trying to represent the data in a different order. Okay, and because we are using the same table name, we are using alias here. T1 is the alias, T2 is the alias, and now as keyword has not been needed here, it's okay if you don't want to use it. Okay, it's like an optional thing. So what we have done here is, there's an example, we have this table and we want to fetch the data. So the following SQL statement matches customers names that are from the same city. Okay, so we want to find out, hey, in this table I have a customers and I want to find the name of the customers who belong to the same city. Okay, so find out which customers belong to the same city. So we say select a dot customer name and customer name 1. Okay, and then we say b dot customer name as customer name 2, a city from customers a and customers b. Okay, so the main thing here to note is that we have customers and customers. So same table has been used here, but we have provided a as the alias, b as an alias, just for easy understanding. So we have table A and table B. So we say go into table A, customer name, and then go into table B, customer name. So we are referring to the same column twice from the same table with different aliases, with different nicknames. And then we're going to name this as customer name 1. Again, so because we're getting the 2 same records, we can set the alias to the table name as well. So we have said as customer 1 and the second customer name as customer 2. And then find out the city. So say where A customer ID is approximately equal to B customer ID, and clause to make sure that we get these 2 things. So we find a customer that are same in both in these tables, which would be same, but then have a same city name, is equals to same city name. So go into table 1, find out the city name is equals to, it matches the city of 2, and order them by city. So if you execute this code, hit the run button, you would get customer name 1 as customer name 1, we get customer name 2, we get as a customer name 2, and we found out the city name. So now what we get 2 names. These 2 people belong to the same city. These 2 people also belong to the same city. these two people belong to the same city. The difference here is again that we are trying to find out SQL statement of the customers that are from the same city. So typically that would be difficult, or in other words, very uniquely complex to find out. But in order to use the self join, we can very easily join the same table and match the same customer ID and then match the same city and then print it. This way we get what we call a data that has matching values. So we say we have a customer name 1 and customer name 2, and this way from within the table we found out, hey, this customer and this customer, they both belong to the same city. Okay, so if I want to find out, and then I can even further complex this query, write more join, and I can say, okay, just group these together. That way I don't have binos so many times. So I can find out all the possible employees or all the customers that belong to the same city or same area. We can easily reuse the same query here. So this is what the self join basically allows us to do. So we combine same table, but we just give it different aliases and behave that, hey, they are two different tables. In other words, this is how simply we define it. So self join is like you give name to the same table and then you assume and behave like, hey, these are two different tables, because now it's table A, table B. They're actually referring to the same thing. So that's why we use this greater than less than sign together. So they said, hey, find out the customer ID that actually belongs to each other, and then the matching city name. So now we get the same city name for two different employees. Capish? Okay, so I hope this explains and clarifies the joins within our system. So if you're following me, do subscribe, and I'm now going to talk more about the next topics and next lessons. See you then.